Hi ladies and gentlemen, this is Mr. Green. This is another in a series of Algebra 2 lessons. Today we're going to be talking about Cramer's rule. Anyone ever heard of Cramer? Mathematician. He worked with matrices a lot. So just, yeah, a little extra knowledge there. No big deal. So you should be finishing Unit 6, working on Unit 6, excuse me, not finishing it. Working on Unit 6 and working in some study island work as well. Don't forget, we got due dates that we have to worry about. We don't want zeros in the grade book. We got to make certain we get things taken care of before they're due. Okay. We're looking at Unit 6.07 and 6.08. This is dealing with determinants and Cramer's rule. Okay. So let's look at this. A determinant is a way of taking a matrix and getting a single value, a number out of it. So if we're looking at square matrices, 2 by 2s, 3 by 3s, 4 by 4s, 5 by 5s, etc., we can get a single number that represents the, quote, determinant of that matrix. Okay? So how do you find the determinant? It's very easy. You write it as either determinant A or with absolute, looks like absolute value lines around the matrix there. But that's the way you write the determinant. And what you're doing is you're going to take AD minus CB. AD being this one minus this one here. Just like this. 6 times 2 is 12. 5 times 3 is 15. Minus 15. That's going to give you a negative 3. That is the way you determine the determinant. You just follow the pattern there. Okay? So if you see the bracket lines, that means it's a matrix. But if you see the absolute value lines, the vertical lines, that means it's a determinant. So you have to be very careful with that. So 6 times 2, 12. 15 minus 15. 5 times 3 is 15. Minus 15 gives you a negative 3. That's one I just worked. Okay? Let's work this one over here. 7 times 5. That's 35. Negative 6 times negative 4, that is positive 24. So it'd be minus a positive 24, which is going to give you an 11. Easy enough to do. We found the determinant of these two. 2 by 2 matrices are easy. 3 by 3 get more complicated. Okay? We can only do that cross like that if it's a 2 by 2 matrix. So what I'm going to do is I'm going to break this down into some 2 by 2 matrices. The first one is going to be, I'm going to take that first number, 1, this one right here, and I'm going to look at everything that's not in that matrix, this data right here. So I'm going to take and do the cross on it. So 2 times negative 1 is a negative 2, plus, I'm sorry, minus 2 times 1 gives me a 2. And then I'm going to subtract. And why? Well, there is a matrix that you will find in the lesson that tells you to do plus, minus, plus. And it just goes across, alternating like that all the way across. So this is what we're going to do. Minus 5 times the things that are not in that matrix. So it's the minus 3 times the minus 1. That gives me a positive 3. Minus 3 minus 1, 3 times 1 is 3. And why did I multiply those? Because those are the ones that are not in the column with the 5. Okay? So then I'm going to say plus negative 4 times the ones that are not in that. Negative 3 times 2 is a negative 6. Minus 3 times 2 is 6. And what do I get here? I get negative 4 minus 0 plus negative 4 times a negative 12 is a 48. And so this becomes a 44. Okay? Difficult. I agree. It's not an easy process to find the determinant of a 3 by 3 matrix. Let's try it with a calculator. See if we get anything better with it, okay? So let's do a clear here. And let's do a second matrix. And we're going to look at matrix A. And I believe I've got it in there. 1, 5, negative 4, negative 3, 2, 1, 3, 2, and negative 1. The easiest thing to do here is to do a matrix. And if you go to the math, the one right over here, math, the first thing is the determinant. So I'm going to do the determinant of matrix A. And do a parenthesis here. And hit enter. And it will give me the value 44. Ta-da! We got the same value. Okay? So the calculator can actually find that determinant a little bit easier than you can. Easy enough. Okay? So how do we use that determinant? Well, using Cramer's rule to solve a system with two equations. What we're going to do is we're going to look at a system of equations. They have to be written in standard form. Ax plus by equals c. So you get it like this. Then you can use the coefficients, 2 and 3, 2 and 3, and 5 and negative 4, 5 and negative 4. Those become a coefficient matrix, and my constant matrix will be these values out here, 16 and negative 14, 16 and negative 14. Okay? So we're going to use that information to write and solve a equation. So we've got our matrix, which is 3 and negative 1, 2, and 2. We've got our constant matrix, which is negative 11 and 6. And what we're going to see here is if we find the determinant of this matrix here, well, 3 times 2 is 6, minus a negative 2, which is equal to 8. Okay? We can then take x and say that x is going to be equal to, I'm going to replace this first column with my constants. And I'm going to find the determinant, negative 11, 6, and negative 1, 2. And divide that by 8. Negative 11 times 2 is negative 22, minus negative 8, plus 8 divided by 2, divided by 8, which is going to be equal to 16 divided by 8, negative 16 divided by 8, which is a negative 2. Y will be equal to the determinant of 3, 2, negative 11, 6, finding the determinant of that, divided by 8. Well, 3 times 6 is 18, minus a negative 22, divided by 8. That's 40 divided by 8. That's 5. Y is equal to 5. Let's see if that works out. 3 times negative 2 minus 5. 3 times negative 2 is negative 6. Minus 5 is equal to negative 11. Check. Okay? 2 times negative 2 plus 5 times, or 2 times 5, that's negative 4, and 10, that's giving me a 6. Check. Check, check. We got it to work out for us. Good. Okay, let's solve well, that's the one we just solved. Okay? So, let's look at a bigger one. Does it work out the same way? It does, but it gets a little bit more complicated because we've got 3 by 3 matrices here, and you're going to have to solve them down to get to find the determinant of them. Okay? But it does work out to be the exact same thing. You can find the x, y, and the z. It is a complicated thing, but you can do it. Let's set this up. So my matrix is going to be negative 1, 1, and negative 2, 2, 5, and negative 1, 2, negative 4, and 3. And my coefficient constant matrix here is going to be 2, 13, and negative 4. Okay? And so if we try to go through and find the determinant of this to begin with, negative 1 times the determinant of 5, negative 1, negative 4, 3, minus 1 times the determinant of 2, 2, negative 1, 3, and then minus 2 times the determinant of 2, 5, 2, negative 4. Okay, 5 times 3 is 15, minus 4. 15 minus 4 is 11. So that's a negative 11 minus 6 minus a negative 2 is 6 plus 2 is 8, and that'd be minus 8. Minus 2 times negative 4 is a negative 8. Minus 10 is minus 8 minus 10 is a minus 18. Okay? That's negative 19 minus 2 times negative 18 is negative 36. So we're going to add 36 to it. Let's see here. Clear. Negative 19 plus 36 gives me a 17. So that's going to be what my determinant is going to be for M. Okay, now you want to check that, make certain we get it correct. Let's go into matrix, edit, 3 by 3, and it's going to be a negative 1, 1, oops, okay, sorry, second matrix, go over to edit, so 3 by 3, and it's negative 1, enter, 1, enter, negative 2, enter, 2, enter, 5, enter, negative 1, enter, 2, enter, negative 4, enter, 3, enter. Okay, second, quit, second, matrix, math, determinant, second, matrix, A, and hit enter. And I get a 17. It's always nice when you get them right the first time. Okay? Now I'm going to pause the video here while I key in the rest of these matrices real quickly so you don't have to watch me do that. Okay, back at you again. It didn't take me long to enter those in. I just wanted to make certain you knew that I was doing that. So I'm going to show you what I've done. I'm going into matrix. I'm going to show you what's in matrix B here. In matrix B, I've got a 213, negative 4. That's these values, 213, negative 4. Then the rest of the normal M matrix. 1, 5, negative 4, negative 2, negative 1, and 3. Just like these. Okay, I can assure you C looks the same, but I'll just show you what I'm doing. C looks like this. It's negative 1, 2, negative 2. I'm replacing the 1 with this 2 here. And then 2, 13, negative 1. And 2, negative 4, 3. That negative 4 is this value right here, not the value that's in the, it's here, use this. It's this value right here, not the value that's in the matrix. Okay? So, that's what I've got for C, D, and for E. I've put these values in. This one is B, this one is C, and this one will be D. Now, Cramer's rule basically says that X is going to be equal to that changed matrix, the one that I've got out there right now, the determinant of B. So I'm just going to write determinant of B divided by the determinant of the matrix, which was 17. So let's do that real quickly on the calculator. So let's find the determinant of B. So I'm going to do second matrix, go over to math, select determinant, and I'm going to do second matrix, select matrix B, and hit enter, and then hit enter on that again, and it'll tell me that it's 51. 51 divided by that 17 is going to tell me that my X value is a 3. So I've got x is equal to 3. Now, y, when I work out the determinant on that the next matrix, second matrix math, I'm going to do the determinant, and it's going to be on second matrix. It's going to be C, which is the third one there. And I hit enter. It's going to give me a 17. So y is going to be 1. That's going to be easy. Okay. And then z will be the last one here that I'll work that one out. I'm doing a second matrix math determinant second matrix, and I'm going to do D, which is number 4, and hit enter, and it's going to tell me that's a negative 34. That's going to be a negative 2. So I found my values for x, y, and z. Want to check them out? Let's do negative 3 plus 1 minus 2 times negative 2. That'd be plus 4, right? Negative 3 plus 1 is a negative 2, plus 4 is a 2. Check. Check each one of them. They'll work out every time. That's Cramer's rule. Makes it easier to solve these. Okay? Using Cramer's rule, you can determine whether each system has a single solution. How? I can tell you real quickly. If I've got a positive number right here. If this number is positive, I'm going to have a single solution. It's easy to do. So this one, my equations, or my matrix is going to be negative 2, negative 8. Y is going to be 1, 4. And so if I figure this out, I get a negative 8 minus a negative 8 times 1, 8. That's going to give me a 0. Nope, it's not a positive number. Not going to work. Let's do this one. Oops, not in standard form. So I got to add the 2x to both sides, and I'll have 2 and 3. Add the x on that one, and I will, or subtract the x on that one. I'll have negative 1 and 5. Hope you guys see where I got those from. I just moved those around real quickly in my head. 2 times 5 is 10, minus a negative 3, and I get a 13. So my determinant is a 13. Yes, there will be a single solution. Make sense? This one can't be because I'm dividing by 0. No. This one, positive 13. Yes, I will have a single solution. Okay? I appreciate you guys telling me that you're in Algebra 2 when you send me K-mails and emails and things like that. It really does help me find you quicker and help me answer your questions a little bit quicker. I look forward to seeing you either in tutoring on Monday, Tuesday, Wednesday, or Thursday. And let's see here, what else? I guess I'll see you next time. Bye.